Friends, today in this lecture we will discuss about with the concept of theory of relativity how we can add the velocities, means addition of velocity. We are familiar with the coordinate systems. Here we are considering a system S is moving with a uniform velocity v are relative to the system S. Means S prime is moving with a velocity v relative to the system S. Suppose a particle is moving in the common direction of the x and x prime axis. Let its velocity as measured by an observer in the system S be at u, and as measured by an observer in S prime it will be a u prime. Then we having u equal to dx by dt and u prime equal to dx prime upon dt, means a rate of displacement with respect to time. Yeah. And for these things we will use the Lorentz inverse transformation equations, and by which we will get here x equals to x prime plus v t prime root of minus v in bracket v square by c square, and t equal to t prime plus v x prime by c square upon root of 1 minus v square by c square. And differentiating about these two equations, here we will get dx equals to dx prime plus v into dt prime root of 1 minus in bracket v square by c square, and dt equal to dt prime plus v dx prime by c square root of 1 minus v square upon c square. And by solving all these things by dx by dt, by taking this ratio uh, here, this factor in here, we will write here this in denominator, and by solving it we get the addition of velocity, that is u equal to u dash plus v 1 plus u dash v by c square. See here, if we are going to put u prime equal to c and v equal to c, that is the photon is moving with a velocity c in frame s prime, and s is moving with a velocity c relative to s, and then u equal to c plus c divided by 1 plus c square by c square, and by cancelling these factors we will get only a c. And c here, the important 3 points is written here. The law of addition of velocity applies only when the two velocities are in the same direction. See here, when we are adding the velocities, at that time it occurs only the two velocities are in the same direction, moving in the same direction. And if v is very less than c, then we get the classical equation, and we can third one we can express the velocity u in terms of u and v, and here u prime equal to u minus v upon 1 minus uv by c square. In this way, the addition of velocities takes place in concern with the theory of relativity. Uh, we have to consider these three things. And friends, again I am repeating the thing that see, as the government and university instructed that the offline classes are started and get vaccinated and attend the theory classes as well as the practical will be started earlier, and therefore if we are attending the classes means you have to attend the classes and then the concept will clear to you. Thank you very much. Again we will here we will see the another article that is a very popular equation mass energy equivalence, and we will see it. Thank you. Yeah. The next point after the addition of velocities we will see variation of mass energy equivalence. By this article we will learn very important equation that is E equal to mc square, which is known as Einstein's mass energy relation. See, very simple thing. Force is defined as a rate of change of momentum, and therefore these things in the form of equation we can write F equal to d by dt in bracket mv, the momentum. Equation number 1. According to the theory of relativity, the mass and velocity are variable both, and therefore F equal to d dt in bracket mv, we can write m dv by dt plus v into dm by t. Equation number. Let the force F displaces the body to a distance dx, then the increase in the kinetic energy dE by Q of the body is equal to the work done. Work done is a force into dx. This is displacement and this is force. And hence we can write here dE suffix k equal to F into dx. And by putting the values of F as we have been derived it in equation number 2, and therefore d suffix ek equal to m v into dv plus v square k. By solving this, according to the law of variation of mass and velocity, we can write m equal to m0 root of 1 minus v square by c square. This will be the fourth equation, and squaring this equation on both sides, that is therefore it will be m square square of this side. You can see here m0 square upon 1 minus v square upon c square, and we will get this factor, or solving it we will get m square c square minus m square v square equal to m0 square c square is nothing but m square c square equal to m0 square c square plus m square v square, and by which here differentiating the above terms we will get c square 2 and dm equals to m square 2 3 dv plus v square 2 m dm, and c square dm equal to mv into dv plus v square dm. Fifth equation, and from equation 3 and 5, this is the fifth one, we will get d suffix ek equal to e square dm. Thus from this equation we can say that a change in kinetic energy, this is a change in kinetic energy, is directly proportional to a change in a mass dm. when a body is at rest, its velocity is zero. That is kinetic energy is equal to zero and m equal to m0. When its velocity is v, its mass becomes m. And therefore integrating the equation, then we will get here Ek equal to integral of dEk in between 0 to Ek and equals to c square integral of dm between the m0 to m, and by solving it c square equal to m minus m0. And friends, by solving this we will get Ek equals to mc square minus m0 c square. This will be equation 7. This is the relativistic formula for kinetic energy. When a body is at rest, the internal energy stored in the body is the sum of kinetic energy, that is Ek, and the rest mass energy m0 c square. By taking the summation of these factors, that is equal to Ek plus m0 c square. See here, putting the values in this way, and we will get here mc square minus m0 c square. These quantities will get cancelled, and by this simply we get E equal to mc square, and this is nothing but the Einstein's mass energy relation, which is one of the popular relation, and this is nothing but the mass energy equivalence in concern with the relativity. Thank you very much. We will meet next time. Thank you.